Hello everyone, welcome back to the lesson. Today we are going to learn combined variation. Here, you need to determine the relation between three or more variables for a combined variation. So let's see what is the combined variation. Combined variation involves a combination of direct variation and the inverse variation. So previously you learned the direct variations. Y varies directly as S, and Y varies inversely as Z. So the combination of these two will give you this one. So another combination is joint variations and inverse variations. So the joint variation is like this: Y varies directly as W, and S, and Y varies inversely as Z. So these two combinations will give you the combination like this. So these are the combined variation. In general, for combined variations, Y varies directly as S power to M and inversely as Z power to N can be written as like this. Y varies directly as S power to M and inversely Z power to N. This is a variation relations, and when write into the equation form is Y equal to K, where K is a constant, S power to M and Z power to N. So M can be 1, 2, 3, 1 over 2, 1 over 3, and N also can be 1, 2, 3, 1 over 2, and 1 over 3. Now let's try how to write the variation relation and equation of this example. So the first examples, Y varies directly as W. So how do you write? Y varies directly as W and the cube of S. So and the cube of S inversely as the cube root. So inversely we have to write in the denominator the cube root of Z. The cube root of Z. And in the equation form, Y equal to, so we just put a constant here. So W as cube over cube root of Z. So the second examples, Y varies directly as the product of W square and square root of S. So we write Y varies directly as the product means the multiplications of W square and the square root of S, and inversely as Z power to 3. So inversely we have a denominator, inversely Z power to 3. So when we write in equation form is Y equal to, so we put a constant, okay, then W square square root of S, then over Z power to 3. We continue with some examples. Example 1. It is given that Y varies directly as the square of S and inversely as the square root of Z. If Y equal to 8, when S equal to 4 and Z equal to 36, express Y in terms of S and Z. So first step you need to do is you have to write the variation relation. So according to this, Y varies directly as the square of S. So first you have to write Y varies directly as the square of S and inversely as the square root of Z. So inversely, therefore we need to write in the denominator the square root of z. So what you need to do next is you have to write into the equation form. So y equal to, just put a constant here, s power to 2. So square root of z here. So we need to substitute y equal to 8, s equal to 4, and z equal to 36. So y equal to 8, s equal to 4, and z equal to 36. Then we try to calculate here. So a equal to 16k over 6. Then we rearrange. So we got k equal to 8 multiplied 6 over 16. So finally you will get a constant 3. Then we substitute k equal to 3 into the equations, so you will get y equal to 3s squared over square root of z. So you have expressed y in terms of s and z. We look at example 2. This table shows the values of p, q, r. So it is given that p varies directly as the cube of q and inversely as r. Calculate the value of s and y. So what you need to do first is you have to write the variation relations. So according here is p varies directly as the cube of q. So p varies directly as the cube of q and inversely as r, so you have to write over r. Then the next step, you have to write into the equation form. You just put a constant here, k, so q cubed over r. Then you need to substitute the value of p, q, r, where p equal to 4, q equal to 2, and r equal to 0.6 into these equations. You 0.6. So rearrange it. So you will get k 3 over 10. So your equation will be p equal to 3q cubed over 10 and r here. So from this equation you can find the value of s by substitute p equal to 3.6 and q equal to 6. So you can write when p equal to 3.6, q equal to 6, and r equal to s, you substitute these three values into the equations. So now your p is 3.6, then your q is 6 power to 3, and then your r is s. So you need to rearrange it to find the value of s. So you will get your s is 18. So now you need to find the value of y, so you need to use this column of values. So you need to write when p equal to 0.081, q equal to y, and then r equal to 0.7. So you substitute into the equations. So your R equal to 2.7. So what you need to do now is you rearrange it. Okay, so you got y power 3 equal to 0.081 multiply 10 multiply 2.7 and over 3. So since you find y, so you need to remove the cube here. So when you remove the cube here, the right hand side will become the cube roots, and you will get y equal to 0.9. So you have found the value of s and the value of 9. Now we move on to the second learning standard, that is solve problems involving combined variation. How to solve problems involving combined variation? Number 1. The pressure P on the tire of a wheelbarrow varies directly as the mass of the wheelbarrow M and inversely as the surface area of the tire touching the ground L. Okay, so you can see that the pressure here is represented with P Newton per meter square, and the mass is represented with M kilogram, and the surface area is represented with L meter square. So it is given that the pressure of the tire is 45000 Newton per meter square when the mass of the wheelbarrow is 19 kilogram and the surface area of the tire touching to the ground is 0.02 meters square. So you need to calculate the value of P, the pressure, when the mass is 120 and the area is 0.5. So the first step is you need to write the variation relations. So for these problems, the variation relation is like this. The pressure P varies directly as the mass of the wheelbarrow. So P varies directly as the mass, and inversely as the surface area of the tire touching the ground L. So inversely over L. Then next is you need to write into the equation form. So P equal to K, you need to put a constant M over L. And then you need to substitute the pressure 45000, the mass 90, and the surface area 0.02 into this equation. 45000 into equal to K, the mass is 90 and the L is 0.02. Then you rearrange it and your K is 10. So the equation is P equal to 10 M over L. Now, when the mass equal to the the mass, okay, and the surface equals to 0.5, so P equal to, you have to substitute 1, 2, 0 and 0.5 to the equations. So the pressure is 2400 Newton per meter square. What can be done to reduce the pressure of the tire if the mass of the wheelbarrow is fixed? So still remember, this is the equation that you found in part A, where the pressure equal to 10 M is a mass, and over the surface area. So what can be done to reduce the pressure of the tire if the mass here is fixed? Okay, so If you want to reduce the pressure, you need to increase the surface area. So therefore, you have to use a broader tire because the pressure on the tire reduces when the surface area of the tire touching the ground increase and the mass is fixed. There are some exercises for you to try, so complete self-practice 1.3a, self-practice 1.3b, and extensive practice. So that's all for today. Enjoy your day and see you next time. Bye.